Hello, class. Today we will be going over sections 11.5, 11.6, and 11.7 of the chapter review. Before we begin looking at our sections, I want to first go over theorem 11.5, which is Euler's theorem. I want to describe the different things that they're asking in this theorem. You have F for your faces. Your faces is the outside parts of my geometric figure. The vertices we know are the turning points, and that's the different turning points on a geometric figure. You have E for the edges, and edges is the parts that actually draw out that geometric figure. Those are called my edges. So now you're familiar with the different terms for Euler's theorem. Let's turn to page 800 and look at number 17. The direction says use Euler's theorem to find the value of n. On 17, my faces is 20, the vertices is unknown, and the edges is 30. You have a formula to use. Your formula is F plus V equals E plus 2. F is my faces, V is my vertices, E is the edges. On the given information, I know that the faces is 20, the vertices is unknown, the edges is 30, and then I write the plus 2. Very simple algebraic equation. I'm going to solve for V. So to get V by itself, I want to go ahead and start off by writing 30 plus 2, and I want to move 20 from the left of the equation to the right, so I subtract. Add and subtract from left to right. I know 30 plus 2 minus 20 will give me 12. So my vertices is 12. Look at number 18. On 18, the given information, my faces is unknown, my vertices is 6, and my edges is 12. So again, I want to plug this into my formula. So I have 6 for my vertices, 12 for my edges, and then plus 2, which is in the formula. From there, I want to solve for F. I have 12 plus 2. I move the plus 6 to the right, and it becomes minus 2. Add and subtract from left to right, and I have 8. For number 19, my faces is 14. My vertices is 24. My edges is unknown, and I write my plus 2. If you notice on this step, I reversed the entire equation. I wrote the E plus 2 to the left and the 14 plus 24 to the right. So I can just see E to the left side of my equation. From here, I want to subtract 2 on both sides. And I add and subtract from left to right, and I have 36 for number 19. Now let's look at section 11.6, which is volume of prisms and cylinders. On number 20, the direction says find the volume of the right prism or oblique cylinder. Round your answer to 2 decimal places. On number 20, I have a prism. In your prism, your formula is your base times your height. Or your base, if you look at a prism, it's nothing more but a rectangle. So the base is a rectangle, and we'll have to take the area of rectangle, which is length times width, and then of course we write our times height. So you can use either one of these formulas to find the volume of a prism. If you look at the given information on number 20, and again, you want to remember that when you are multiplying, it does not matter how you arrange the numbers, it's going to all come out the same. So I want to use this formula. Since I see 3 numbers, I have a length, a width, and a height. So I want to plug in all of my 3 different numbers that was given on number 20, which is 1.5 times 2.1 times 3.6. I'm going to multiply all those numbers together to get 11.34. And when you're measuring volume, the units is in meters to the third, or cubic meters. On number 21, you need to read theorem 11.7, the volume of a cylinder, which is on page 752. Your formula is volume equals base times height. But when you think about a cylinder, think about an ice cream cone, okay? We know that the base of a cylinder is a circle. So the base of a cylinder is nothing more but the area of a circle. So you can use either formulas to work with this particular problem. So volume is pi r squared h. We know r is radius, h is height. On the given information, if I look at my information, they gave me the radius. The radius is 2. So I want to use my second formula instead of the first one because they gave me a radius of 2. And they gave me my height already, which is also 8. So from here, I just take my calculator, and you should be very familiar with the calculator by now. You're going to say second pi times 2, hit the x squared button, times 8, and you should get 100.53 millimeters to the third power. Number 22. 22 is very similar to one of the examples that we completed on one of our previous sections. You have to remember SOHCAHTOA to do this one. We know SOHCAHTOA is sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And we know that's just an acronym that's used to talk about the different trigonometric functions. Okay, very important. But on number 22, if you look at this information, I see a pentagon. Okay, so we have a pentagonal prism. But we know a pentagon has 5 sides. They have the red markings letting me know that all 5 sides of my pentagon is 2 yards. Okay. Now, we talked about the term, the azimuth, okay? We talked about that term on the previous section. That's a little tricky, but you need to go back and review over it again if you don't remember. So to find the azimuth, you need to first find the measure of the central angle. And the azimuth is the part right here that's drawn in pencil. That is what I need to find. But I need to first figure out what my central angle is. So to find the central angle, I have to apply my formula, which is 360 divided by the number of sides. Now I know that a pentagon has 5 sides. So 360 divided by 5 will give me 72 degrees. If you look at this figure, when you draw that azimuth, you have 2 congruent sides. So this side is 1 and that side is also 1. So that means that this segment bisects this angle. And I know that this total angle is 72 degrees. So if I take 72 degrees and divide it by 2, I get 36. So this small angle here is 36 degrees. Now if you notice the next step, I drew out what I just said. I took one of these triangles and I drew it out again. And it forms a right triangle. So you need to put your little indicator showing that it is a right triangle. Okay. So I know that this is 36 degrees. And I know that this length here is 1. And I need to still find my azimuth. Okay. Which I have a question mark. So you have to remember the SOHCAHTOA. If I look at 36 degrees, that is my angle. That's my theta. So if that is theta, that makes one opposite, and the one in question is my adjacent. So which formula has opposite and adjacent in it? And I know that the tangent formula is opposite over adjacent. So if I look here, I got tan, my theta is 36 degrees, equals 1, which is opposite, over my adjacent, which I labeled as y. It doesn't matter which angle which letter you use for the unknown. So I use y. And the reason I use y is because my side is vertical. So that's why I use y. I'll use X for horizontal and Y for vertical, but it really doesn't matter in this case because it's still going to come out correct. From here, I need to cross multiply. So to cross multiply, I have y times tan 36 equal 1. Divide both sides of my equation by tan 36. The tan 36's cancel out to 1. Type in your calculator 1 divide tan 36 degrees and you should get 1.3764. And you want to make sure that your mode on your calculator is in degrees. Now from here, we're talking about the apothem again, which is that lowercase a. So I'm trying to find the area of my pentagon. So to find the area of the pentagon, I'm going to use a previous formula that we used in a previous section of this chapter. Or I also found another formula for a pentagon, which is 5/2 times my side times my apothem. Now we know that the side of the pentagon is 2 yards. So for here, I could have just said 5/2 times 2 times my apothem, which is the 1.3764. Okay, and then you'll get an answer. You'll get your answer, which is the same as using the first formula. But since you are familiar with the first formula from previous notes, we're going to go with this formula instead. So to do my area, I'm going to say 1/2 times my apothem, which is the 1.3764, times my perimeter. Now, we remember perimeter. Perimeter means we're going to add all the sides. So you look back at your picture. I'm going to say 2 plus 2 plus 2 plus 2 plus 2. So to keep it simple, we just say 2 times 5, which we know is 10. On your calculators, you should know how to use your calculators. Type this in, and you should get 6.8819. Almost done, but not quite. We have to find the volume of the pentagonal prism. And that formula is volume equals the area times the height. Now, we have found the area of the pentagon already, which is 6.819. And then the height, if you look at your diagram, is 4. So when you type in these two numbers, the volume is 27.53 yards to the third. So for this particular problem, you had to do so many steps, but it's very easy if you just follow the steps. So let's just review it one more time before we go on to the next section. So again, on this section, I had to identify what my apothem was. So in order to do that, I need to find the measure of my central angle, divide that number by 2 to get 36 degrees. Okay, from there, I had to find out what was the apothem. And to do that, I had to use my tangent formula, which is opposite over adjacent. And that's what I did here. I had to cross multiply to solve for y. And we know that y was approximately equal to 1.3764. Now from there, I had to find the area of the pentagon, which I could use either formula to find. It doesn't matter. So once I plugged in that formula, I found that my area is 6.8819. And I had to do all that because to find the volume of a pentagonal prism, the formula is volume equals area times the height. So the area is 6.8819 and the height is 4. So we got 27.53 cubic yards. Now, looking at the last section, which is section 11.7, number 23 says, a cone with diameter 16 centimeters has height 15 centimeters. Find the volume of the cone. Round your answer to 2 decimal places. So you need to go back and read Theorem 11.10, which is on page 763, which talks about the volume of a cone. Thinking about what was read, I know that the diameter given was 16 centimeters. So we know half a diameter is radius, which is 8 centimeters. The height is 15 centimeters. So to find the volume of a cone formula, you can use either formula you like. So volume is 1/3 base times height, or 1/3 pi r squared times h. And remember that when you think about a cone, think about an ice cream cone. The base of that cone is a circle. So the base is the area of the circle. Since I have diameter and radius and height, I will use the second formula instead of that first formula. Right here, I have 1/3 pi. My radius, we know, is 8 squared times my height, which is 15. If you notice here in red, I simplified 3 and 15 simplifies to 1 and then 5 here. Okay, so 15 over 3 simplifies to 5. And I cleaned up my problem, as you notice, on the second step. So I have pi, 8 squared is 64, and times 5. Calculators, you type it in, and you want to make sure you press second pi to get that number, times 64 times 5, and my answer is approximately equal to 1,005.31 cubic centimeters. Look at our last example, which is number 24. 24 says, the volume of a pyramid with 60 cubic inches and the height is 15 inches. Find the area of the base. You need to read Theorem 11.9, which is the volume of a prism, pyramid, and your formula is volume equal 1/3 base times height, or volume equal 1/3 length times width times height. Okay, so to find a pyramid, we need to use either one of these formulas. And one thing you got to pay attention with a cone and a pyramid is that in a cone, the area is a circle on the base, and then the base of a pyramid is a rectangle. So you want to pay attention to that. So that's the difference between the two. So pay very close attention to that. So on this one, it's a little different. This time they want to know what the area is. So we're trying to figure out what that base is. Okay, so on this one, we have the volume is 60 cubic inches. Okay, very easy. And we know it's volume because it's to the third power. And the height they gave us is 15 inches. So I need to find out the area of the base. I want to plug it into my formula. If you notice, I'm using the first formula this time because we're trying to find out what the base is. So I want to use the first formula instead of that second one. I have 60 for my volume equals 1/3. My base is unknown times my height, which is 15. Again, I want to simplify that 3 and that 15. So I know 3 going to 15 5 times. Right here, I know 1 times 5 is 5 times my base. Divide both sides of my equation by 5, and 5 goes into 60 12 times. So the base, which we know is an area, is 12 inches squared. Okay?